Hi and welcome to Cherry Pie Math. This video is going to go over some applications of scientific notation, and more specifically later in the video about how to convert a repeating decimal to a fraction. Okay, so a very common way you might see scientific notation in your studies is in chemistry when you're introduced to the unit of a mole. That's a measurement of atoms. It's like how we say a dozen to mean 12, only a mole, or Avogadro's number, represents 6.0221476 times 10 to the 23rd of atoms. So I want you to pause the video and I want you to see if you can answer what that might look like in standard form, or not in scientific notation, basically. And then at the bottom, there's also a question about a repeating decimal that's not like overly important at this moment in time. It will be later in the video, but it's good to get some practice in before we get there. Anyway, go ahead and see if you can convert it from scientific notation to standard form. Okay, so as a reminder, if it's a positive exponent, then the standard form will be a very large number. So I'm going to be moving the decimal to the right 23 spaces. Okay, so that's going to take a minute. And then you fill in the spaces that you just made with zeros. So you're just going to do 0 and lots of zeros. As a side note, that second question, 0.3 repeating is 1/3 as a fraction. Okay, so we'll get back to that in a second. So another way you'll see scientific notation in real life is with population. I got this information from the site I have in the corner here, but it said that by the end of 2020, there were 96.8 million cases of COVID-19. I'm just going to go through the answers, but if you want to try to guess them, go ahead and pause the video and see if your answers match mine. Okay, so in scientific notation, we will only have one digit in front of the decimal. So if I wrote this out, I'd have 96,800,000, since the million also means 10 to the 6th power. However, since in scientific notation, like I said, we only have one digit to the left of the decimal, it would actually be written as 9.68 times 10 to the 7th, because we aren't just ending at the millionth, we're actually going a little bit further. So why did they use 96.8 million instead of the correct notation? Well, million is such an easy thing to remember and for everyone to understand instead of 7 places to the left of the decimal or 10 million, right? So you'll often see statistics like this where it's just kind of rounded to the nearest millionth or thousandth or billionth or whatever, because it's just easier for our brains to understand. Do you think there were exactly 96.8 million cases? Probably not. But again, humans like to think in nice round numbers. A couple of people off of 96.8 million to the average layman doesn't really change the immensity of that number, so they don't include it. Like if you had like 4 more people, like 96,800,004, when you're talking about it, and it sounds kind of terrible because those 4 people just kind of get lumped in to, like, they just merge with the million. But we don't really care about those extra little numbers. We want to see what's like the biggest checkpoint. What's the nearest rounded number that we can get to? Okay, so another way we see applications of scientific notation is with converting decimals. So as a review, let's talk about how you would convert a terminating decimal to a fraction. Okay, so step 1, you put the digits over the 10th power of the corresponding decimal. So for example, 0.482 ends in the 100th place because in decimals you have, it doesn't start with the ones place, it starts with the 10. So we would have 4 is in the 10th place, 2 is in the 100th place. So I would put 100 in the denominator. Step 2, you simplify. So I like to divide by 2 if they are both even, just to give me a starting place. So if I divided by 2, top and bottom, that would be 21 over 50, which actually is it, since you can't simplify anymore. There are no more common factors. If there was more common factors, then you would divide those out as well. So that's how you convert a terminating decimal to a fraction. You just put it over whatever 10th place it's in, and then you simplify it. But with repeating decimals, you don't have a 10th place where the decimal ends. So we have to use scientific notation to modify this a bit. Repeating decimals are still rationals, meaning they can be represented as a fraction. And so when we're converting this, we have to remember that yes, it is going to be a fraction We are going to make it through. It's going to be okay. So when we're converting a repeating decimal to a fraction, step 1 is to set the decimal equal to x, which is like a definition. So later when we refer to x, it's going to be that decimal. So for example, in the first one, x would be equal to 0.81818181, etc. And in the second example, it would be x equals 0.57 repeating with the bar over the 7. And just as a reminder, you can have an ellipses or you can have a bar on top of a number, and they mean the same thing. It just means that you're repeating that decimal. So just for in the future reference. Okay, so step 2, now that we have x equal to the decimal, is to multiply x, or the decimal, by 10 to the power of the number of digits repeating, or the number of repeating digits. So for example, in the first one, we had 0.818181, right? I'll just write that here. Only 2 digits are repeating, the 8 and the 1, so my exponent would be 2. And if I was to write this out, so I'd have 10 squared times x, but that could also be 100x, or it could be, we're kind of like in scientific notation where we move that decimal 2 spaces to the right, it would become 81.8181. And we're going to be using both forms in the next step. So I would write it out like this. So you have one side with the 100x and the other with the decimal. Okay, in the next example, we only had 1 digit repeating. It was the 7. So it would be 10 to the first power, or 10x on the left side. And on the right side, since we're only moving the decimal 1 space, it would be 5.777. So it really, really helps to have both of these formats, because in the next step, we're going to be doing some algebra with that format. So step 3, we are going to be using the properties of algebra and scientific notation together. So we are going to subtract x from both sides. And one thing to remember, on the left side, when we subtract x, we're going to keep it as x. So we're going to just subtract x, like combining like terms. On the right side, though, it will be easier to subtract the decimal. And I'll show you why here in a second. Okay, so in the first example, we had 100x equals 81.8181. We had determined that previously. And so now I'm going to subtract x from the left side, and I'm going to subtract it from the right side as well. 100x minus x is just 99x. We have 1 less x than we started with on the left side. But on the right side, I'm actually going to convert it back to its decimal form, because I can do that. The x and the decimal mean the same thing. The reason for this is now my decimals match up. I can actually just do like the 818181 repeating is subtracting the 818181 repeating, and it just is gone. So I'm only left with that 81 from before that decimal point. Same idea in the second example. I'm going to subtract x from both sides, so the left side would be 9x, but instead of having the x on the right side, I'm going to change it back to the decimal, so it'll be 0.577. This one's a little bit different because it doesn't match up completely. Most of it does. Most of the 7s will match up, but that 5.7 does not match up with the 0.5. Everything else does. I can get rid of it, but I'm going to have to do 5.7 minus 0.5 separately, which isn't a really big deal. All you have to do is subtract it, and so you end up with 5.2. So that's going to be what's on my right side now, because I got rid of the rest of the decimal. Everything else that I couldn't get rid of, I did the subtraction for. Now I have 9x equals 5.2. The first one is a lot easier because those match up. The second one, you're going to have to do a little bit more math. But the same idea applies, where on the left side, you're really just dealing in x's, and on the right side, you're just dealing with whatever you have left over. Okay, step 4 is to solve for x. What that means is to get x by itself. So in the first example, I have 99x, so I'm going to divide both sides by 99. So now I have x and then equal to 81 over 99, and I can simplify that by dividing both the top and the bottom by 9. And so I have x equals 9/11ths, which I can check. So if you go, oh, I don't have a calculator on my app, so I'll go to the internet because I'm lazy. So I'm going to do 9 divided by 11. I'll just write 9 div 11 because I'm lazy to find a division symbol. And 9 divided by 11 is 0.81 repeating. So we were right. Excellent. In the right one, same idea. I want to get x by itself, so I'm going to divide both sides by 9. So I have x on the left side because the 9's cancel out. On the right side, I have 5.2 divided by 9. One thing I can do, because decimals are just dumb and nobody likes them, is I can use scientific notation again. I want to move this 1 to the right, so I'm going to times both the top and the bottom by 10 to the first power, which becomes 52 over 90, since I have to apply it to the bottom as well. And then I can simplify this. This ends up being 26 over 45, and I actually can't make that any smaller. And that's how you would do it. So some things to remember. Earlier in the video, we talked about how the media likes to shortcut scientific notation to the nearest millionth or a thousandth, so just keep that in mind. When you're converting a repeating decimal to a fraction, the exponent of the 10 should be equal to the number of digits of the repeating part only. So even if there's extra numbers in there, you only care about the repeating part. Set up the equation with 10 to the n on one side. So like how I had like 100n or 100x because I did 10 squared times x, and the original decimal on the other, so that you can subtract from both sides, and simplify as much as possible, and double check your answers when you're done. Okay, I hope that helps. Go back and think about and review those 4 steps. I know it can be a little bit complicated, but hopefully if you have those 4 steps in front of you, it'll be easier to see what it's trying to say. Okay, I hope that helps, and good luck.